Metals may be scarce on Earth. As we are mining heavily and using them much more than we ever did, we will soon run out of some precious metals. Actually, we already have a big problem. There is a global crisis of semiconductors. The shortage has come to a point that companies like Apple lost $6 billion in revenue. Some car manufacturing companies also had to cut down at least 50% of their production, and the space exploration companies are also heavily affected. Semiconductors are one of the most essential parts of electronics. Without them, we can never even dream of space exploration, or even bigger and better telescopes to observe the universe and reveal its secrets. It seems we have found a solution floating everywhere in space. Metals have been one of the most important parts of the survival of human race for years. Thousands of years ago, we learned to use rocks as weapons. Then we found the use of metals as weapons. From there, we have come to a point that we need metals for everything we do. As the global economy is facing a great danger because of the semiconductor crisis, a new study by a Belgian team using data from European Southern Observatory's Very Large Telescope has given us the solution we need. There is no scarcity of metals in space. Every rock, every asteroid, and nearly every planet has a lot of it. The new study has shown that iron and nickel exist in the atmosphere of comets throughout the solar system, even those far from the sun. And a separate study by a Polish team who also used ESO's data reported that nickel vapor is also present in the icy interstellar comet 2I Borisov. This is the first time metals have been found in cold atmospheres of distant comets. Usually, they're associated with hot environments. The more surprising fact is scientists detected iron and nickel atoms in the atmosphere of all the comets they have observed in the last 2 decades. Astronomers know that heavy metals exist in comets' dusty and rocky interiors. But because solid metals don't usually sublimate or become gaseous at low temperatures, they did not expect to find them in the atmospheres of cold comets that travel far from the sun. When they were using ESO's Very Large Telescope to observe the comets, they noticed the presence of nickel and iron vapor. They observed about 20 comets at nearly more than 480 million kilometers from the sun, which is equal to more than 3 times the distance of Earth to Sun. Materials in our solar system that are found in the sun and in meteorites usually contain about 10 times more iron than nickel. This new result therefore has forced astronomers to rethink about the solar system's history. The team is still decoding what these are, but what minerals are commonly needed for electronics? Electronics has improved tremendously since the introduction of the first commercial circuits. With silicon dies containing billions of active components, resistors the size of dust specks, and capacitors that can carry obscene amount of charge given their size. However, many of these components, in order to function, rely on minerals that most people have never even heard of. Common elements such as iron, carbon, and aluminum are used in basic components like resistors and capacitors, while lanthanum, cerium, neodymium, and europium are used in LEDs, silicon dyes, and thin film displays. While several of these minerals are classified as rare earth, this does not necessarily imply that they are uncommon, yet many of them are. Mass industrialization is quickly consuming all the rare materials that can be found on Earth's crust. There are now 80 years of uranium reserves available, though this does not indicate that all the uranium in this world will be used up in 80 years. Rather, it implies that proven sources of uranium will continue to provide uranium at a viable rate for another 80 years at the current price. However, there is another factor to consider when it comes to resources: environmental impact. Lithium is an excellent example of this. While lithium is abundant in the Earth's crust, it is dispersed widely, making mining much of it prohibitively expensive. The known deposits of lithium would run out in 3 years if all automobiles on the planet became electric. Of course, fresh deposits would become accessible, allowing lithium to be used in more industrial applications. However, mining lithium has a significant environmental effect, destroying enormous quantities of land and making it hazardous as a result of the byproducts produced during the extraction process. The metal vapor we are talking about was formed around 4.6 billion years ago in the very young solar system and have not changed since the time. In this sense, they are like fossils for astronomers. The team used data from ultraviolet and visual ECHELLE spectrograph instrument on ESO's VLT, which uses a technique called spectroscopy to analyze the atmospheres of the comets at different distances from the Sun. This technique allows astronomers to reveal the chemical makeup of cosmic objects. Each chemical element leaves a unique signature, a set of lines in the spectrum of light from the object. The Belgian team had spotted weak, unidentified spectral lines in their UVES data, and on closer inspection they found out that the vapor was signaling the presence of neutral atoms of iron and nickel. A reason why heavy elements were difficult to identify is that they exist in very small amounts. The team estimates that for each 100 kilograms of water in the comet's atmosphere, there is only 1 gram of iron and about the same amount of nickel. Tell me in the comments below, with taking the cost of retrieving the vapor in mind, will it be effective? Actually, there might be an easier and a cheaper way. The simple solution could be asteroids. Take Vesta, for example. It is one of the solar system's biggest asteroids, has a diameter of around 330 miles, while some of the tiniest are around 2 meters wide. Asteroids are generally made up of rocks and minerals, however, their specific composition varies widely. For example, M-type asteroids are primarily nickel-iron, where C-type asteroids are largely clay and silicate rocks. Gold, cobalt, palladium, platinum, and osmium are also some of the minerals that we have detected in asteroids. So, could asteroid mining be the key to ensuring limitless supplies? While asteroids may contain minor amounts of rare minerals, their size and lack of environment would allow a mining operation to completely destroy an asteroid with no consequences. They are abundant in the solar system and would most likely provide humanity's resource requirements for millions of years. To put things in perspective, the asteroid belt's overall weight is only 3% that of the Moon. Yet, it's still 2.39 into 10 to the power 21 kilograms. Even yet, this only considers the asteroid belt and ignores stray asteroids that circles the Sun, planets, Jupiter and Saturn's rings. We have not yet developed enough technology to help us mine asteroids to develop more technological marvels, but NASA is going to launch a very important asteroid mining mission to an asteroid in August this year. That asteroid is worth $10,000 quadrillion. I'm currently working really hard on an awesome video about that. You must not miss it.